Welcome back to linear algebra. Let's jump into Anki. What is an elementary matrix? An elementary matrix is a matrix that can be basically created from an identity matrix using only a single elementary operation. If the matrix B results from the matrix A by performing one elementary row operation, how might you recover A from B performing one elementary row operation? If you switched rows, switch the rows again. If you multiplied through by a non-constant, multiply through by the reciprocal of that non-zero constant. And if you added a constant to times a row to another row, subtract a constant times the same row to the same row. State three results that are equivalent to the statement that A is invertible. You can express A as a product of elementary matrices. The reduced raw echelon form of A is I, and AX equals 0 only has a trivial solution. Write out the matrix represented by the symbol A sub ij sub 3 times 4, 3 by 4. So we're going to have 3 rows, 4 columns. It's basically A11, A12, A13, A14, A21, A22, A23, A24, A31, A32, A33, A34. If E is an n by n matrix, how might you obtain the inverse of E from I? Again, this is like if you get E from multiplying I by a constant, or multiply I by a reciprocal of that constant. If you got it from swapping rows, swap the rows again. Or that one's the same. You swap if it's an elementary row if it's an elementary matrix that just swapped rows. I think it's just the inverse is equal to the original. And then if you added a constant times a row, if you can get E by multiplying constant of times a row of I to another row, then do that same thing, but instead of adding, you're subtracting. Or you could say adding negative, the negative constant, or the additive inverse. What does it mean to say that matrices A and B are row equivalent? You can obtain one from the other and vice versa by only performing elementary row operations on one or the other. If elementary matrix E results by performing a certain row operation on the identity matrix I, how is the product EA related to the matrix A, assuming that the product is defined? Assuming the product is defined, basically whatever elementary row operation you need to use to get E from I, it's going to be like use the same elementary row operation on A. That's it. Okay. Did I have work to grade from yesterday? I did. So I'm going to grade the work from yesterday, and I'm going to continue doing more work, and then I'll do adding Anki flashcards from previous textbook chapters. Talk to you in a bit. All right, so the problem yesterday, finding the solution to a system of 2 linear equations using a matrix inverse. That was correct. And I finished the problem from yesterday that I was working on, basically showing, verifying that inverse of an upper triangular matrix is, again, an upper triangular matrix. And then I finished up the 1.5 flashcards in Anki, and then finished half of the 1.6 flashcards in Anki. So potentially tomorrow will be the last day of finishing up these Anki flashcards I forgot to input. Other than that, not much else to say for today, so talk to you tomorrow. See ya.